Hi everyone, myself Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. In this video, I am going to discuss about the subject 3D printing and design. The subject code is CCS 331. First of all, I will explain the course objectives and outcomes of 3D printing and design. This course is structured into 5 units to systematically achieve the course objectives and outcomes. The Unit 1 introduces the basic concepts of 3D printing, which help students understand the fundamentals of the technology. Unit 2 focuses on the principles and workflow of 3D printing, enabling students to understand the complete process from design to production. Unit 3 and 4 cover inkjet and laser based 3D printing technologies, where students learn the working principles and categorization of these techniques. Finally, Unit 5 emphasizes designing and modeling methods for industrial applications, helping students apply their knowledge in real world scenarios. Thus, the content is well aligned with the course objectives and ensures the achievement of all defined course outcomes. Let's get into our topic now. What is 3D printing? 3D printing is a method of creating a three-dimensional object layer by layer using a computer created design. It is an additive manufacturing process that creates a physical object from a digital design. To say in a simple definition, creating a physical object from a digital design. For that, it uses a 3D CAM model as input, converts the model into thin layers, builds the object along X, Y, and Z axis. Material used here are plastic, resin, metal, powder, cement, etc. 3D printing is also known as additive manufacturing, rapid prototyping, layered manufacturing, solid free from fabrication. Now we can see the history of 3D printing. In the year 1981, Hideo Kodama filed the first patent for rapid prototyping. He introduced the idea of layer by layer manufacturing and laid the foundation of additive manufacturing. In the year 1984, Chuck Hull invented stereolithography. He uses UV light to cure liquid resin layer by layer. This is the first practical and commercial 3D printing technology. In the year 1988, Chuck Hull founded the first 3D printing company. This 3D printing moved from laboratory research to industrial use. It is used mainly for rapid prototyping. In the year 1992, Carl Deckard and Joseph Beeman invented selective laser sintering. They uses a laser to fuse powdered materials and enabled printing of strong and functional parts. In the year 2004, the key patents were expired and resulted in open innovation and lower cost. In the year 2009, the companies like MakerBot and Ultimaker introduced affordable printers. This 3D printing became accessible to students and small businesses. Also popularized fused deposition modeling. In the year 2011, the first artificial human bladder successfully printed and opened applications in medical and tissue engineering. This enabled research in organ printing. In the year 2015, technologies like direct metal laser sintering and electron beam melting emerged. Then, printing of complex metal parts are allowed and widely adapted in aerospace, automotive, and medical implants. In the year 2016, China constructed the first habitable 3D printed building and demonstrated large scale printing using concrete materials. This reduced construction time, cost, and waste. In the year 2020, during COVID 19, 3D printing was used to produce PPE kits, face shield, and ventilator parts. It showed the importance of rapid, decentralized manufacturing. The next slide, additive manufacturing and subtractive manufacturing. Additive manufacturing means adding material layer by layer. Subtractive manufacturing means material is removed from the solid block. So coming to additive manufacturing, this process involves building objects by adding material layer by layer based on a digital 3D model. It allows for the creation of complex geometries that are difficult or impossible to achieve with traditional manufacturing methods. Coming to subtractive manufacture is the process of removing material from a larger block to create a desired shape using technique like milling, drilling, and turning. Subtractive manufacturing is a process where material is removed from the solid block or stock material to achieve the final product's desired shape. In the figure, the process of additive and subtractive manufacturing is given. See, in additive manufacturing, materials are added layer by layer and there will be less waste. In subtractive manufacturing, materials are removed from the solid block and there will be more waste. So this is about additive manufacturing and subtractive manufacturing. Next come to the process of 3D printing. Here the object is first designed using CAD software. This design represents the object in 3 dimensions as X, Y and Z. Then the completed design is saved as an STL file. STL file means stereolithography file. This STL file describes the surface geometry of the model. Next, this STL file is imported into slicing software. After that, it will be a G-code file. Now, the G-code file is sent to the 3D printer and finally the complete 3D object is formed. So, to summarize this, the object designed using CAD model, then it is saved as STL file. This STL file is converted to G-code and this G-code file is sent to the 3D printer. Finally, the physical object is formed. Now, coming to the working process of 3D printing, there are 5 steps. I will explain this using a pictorial form. So the step 1 is creating a 3D model. The 3D object is designed using CAD software like AutoCAD, SolidWorks, Fusion 360, Blender, etc. So the object is first designed using a CAD software. This model is created in X, Y, Z coordinates, that is length, width and height. For example, a vase or container model as given in the picture. As I explained previously, this designed model is exported as an STL file. This STL format represents the object using triangular surfaces. This file is the standard input for most 3D printers. Next, this STL file is loaded into slicer software like Cura, Prusa Slicer, Simplify 3D, etc. This slicer cuts the 3D model into thin horizontal layers and set parameters like layer height, print speed, infill and supports. Now the output of the sliced model will be a G-code. So this is the step 1 process. Coming to step 2, that is stack of slices. The slicer converts the model into a stack of 2D slices. Each slice represents one layer to be printed. Printing happens layer by layer along the z-axis. Next, coming to step 3, here the printing begins. Now the G-code is sent to the 3D printer. First of all, the printer moves the print head in X and Y directions and deposits material for one layer. Material like plastic or resin or powder or cement can be used. So first of all, the printer moves the print head in X and Y directions and deposit material for one layer. Then move slightly up in Z direction. Now each new layer is printed on top of the previous one. Then layers bond together to form the complete object. This continues until all layers are printed. Coming to step 4, stack of layers. Here the accumulation of all printed layers forms the final 3D shape. The object gradually takes its full height and structure. Next, step 5. This is the final step. After printing is complete, the object is removed from the printer. If any supports is given, it can be removed. And the post-processing may be done like cleaning, sanding, etc. And finally, the design object is received as a physical one. I summarize. The step 1 is creating a 3D model. Here the object is designed using a CAD software and the model is exported as an STL file. Then it is loaded into slicer software. It sets parameters and the output of the sliced model is G-code. Then the model is converted into a stack of 2D slices. Then the printing begins. Here the G-code is sent to the 3D printer and printing begins layer by layer fabrication. And the object gradually takes its full height and structure. Finally, 3D object is designed physically. Now the next, some advantages of 3D printing technology. Speed, cost effective, flexibility, consistency, competitive advantage, risk reduction, sustainability are some of the advantages of printing technology. In the next video, we can learn about design consideration like material, size and resolution in 3D printing. Thank you.